Hey everyone, so today we're going to work on absolute value inequalities. So we talked about inequalities last time in general, so we're going to continue using that interval notation and graphing, but now we're going to talk about what if it's an absolute value inequality. So just to remind you about what is an absolute value, remember an absolute value in general is the distance away from 0. So if I said absolute value of -2, it's 2. Absolute value of 2 is 2. So most people think of it as, it's equal to a positive. It makes it positive. And really it's just saying what's the distance from 0. All right, so if we're going to review, these are kind of algebra 1-ish. If you have an absolute value equal to a number, equal to a positive number, the inside of this is either -2, right? Because then it would be 2. Or the inside of this is 2. So that's kind of the equation you set up. You say, okay, well, either 3x minus 1 is equal to 2, because absolute value of 2 is 2, or 3x minus 1 is equal to -2, since the absolute value of -2 is equal to 2 as well. So let's see what I would get. -1/3 and 1. And these are just equals, so no need for any graphs or anything. When x is equal to 1, we would get 2. When x is equal to -1/3, we would also get an absolute value of -2, which is 2. All right, so that's how you solve those. With an equal sign, we set 1 equal to the positive, 1 equal to the negative. All right. If you're good with that, let's try one more. So when is it equal to 4? Well, either the inside's equal to 4, or the inside is equal to -4. Okay, so if I treat this like two fractions, I can cross multiply here. And I get 3 equals 4 times 2x minus 1. So 3 is equal to 8x minus 4. Wow, I gave you guys plenty of space here, huh? 7/8, sorry about that. X is equal to 7/8, or 3 is equal to -4 times 2x minus 1. 3 is equal to -8x plus 4. So if we subtract 4, -1 equals -8x. X is positive 1/8. All right, let me shrink that down. Sorry about sizing there. Oopsie. Okay, so let's zoom in here. What's going on? So again, we set the inside equal to 4, or the inside equal to -4. And then I basically just ended up cross-multiplying 4 over 1, cross-multiply, and I got 7/8 and positive 1/8. All right, so if you ever wanted to check, you could also plug them in, make sure it works. So I'm going to save that for now and not do that just to save time, but that would be a really useful tool as well. Okay, to finish up, I wanted to show you one. When is the absolute value of 2x minus 3 equal to -5? When is an absolute value equal to a negative? Never. No solution. There's nothing that we can plug in here that will give us the absolute value is equal to a negative. So really important to keep that in mind. All right, so now we're going to talk about absolute value inequalities. Those were equalities, right? Equations. And now we're going to talk about inequalities. So if I asked you whose absolute value is less than 4, okay, so try to think of some numbers right now. When you plug it in, you would get an absolute value of that number is less than 4. I mean, I would say 3, right? 2, 1. How about -3? Yeah, that would work, right? Absolute value of -3. -2, -1, 0. How about 5? No. How about -5? No, because that would be 5 is less than 4. So hopefully you notice these numbers are between, right, -4 and 4, right? Or, well, I actually should say A, not X. Okay, that's kind of what I notice. I picked all these numbers. If I looked on a number line, all these numbers between -4 and 4, those were all the numbers that kind of worked here. All right, well, what about the opposite? What if I said, when is the absolute value of A greater than 4? Well, think of some numbers. How about 5, 6, 10, 100, 50, any number bigger than 4. All right, but the other side, think of that negative. What about -5? Would that work? Well, absolute value of -5 is 5. How about -6, -12, -28? Any negatives, any huge negative number, the absolute value of that would still be greater than positive 4. So in this case, I hope you guys notice, this is kind of values that are greater than 4, but also all the values that are less than negative 4, excuse me. So values that are greater than 4 and the values that are less than negative 4. All right, so that's kind of interesting to us as well. And here's how we're going to use that. Okay, below, less than, greater. All right, so I know I'm using these words wrong. I'm pronouncing them incorrectly on purpose. And yes, it's a little bit annoying, but actually it's going to help you remember this. All right, so if I say if I see a less than with an absolute value, you're going to hear me say less than, and we're going to use an and statement because it's in between when we have a less than. All right, if it's a greater than sign, right, something like there's a greater, there's a greater. I think I said this was less, I didn't mean to, if I did. We have some greater thans. I'm going to say greater because we're going to write this as an or. A is greater than 4 or A is less than negative 4. So we're going to do these very similarly. The process is going to remain the same, but very important difference. Less than is in between an and statement, and or is going to be a union. So something like going this way and going that way. Special cases really quick. When is an absolute value less than a negative? So when is the absolute value of A, less than negative 4? Never, right? So that would be no solution. When is an absolute value, like let's say A, when is that greater than negative 4? So how many numbers can you think where the absolute value is greater than a negative? All of them, right? All real numbers. You could also say negative infinity to infinity, spanning all real numbers. Every number we plug in here would be greater than negative 4. All right. So we're going to try a couple of these, okay? And let's take a look at the first one. So again, we look at it and we say, all right, 7 minus 3x is greater than 4. And again, I'm using these kind of annoying endings here because we're talking about absolute value inequalities. That's the only time this comes up. So when is 7 minus 3x greater than 4? Well, either when 7 minus 3x is greater than 4, or when 7 minus 3x, now watch this, is less than negative 4. All right, so flipped and flipped. I flipped the sign and I flipped the negative and positive. All right, so I write it exactly as it is without absolute values. That's what this is. And then I flip the inequality and flip the sign. Okay, so let's solve this up. Negative 3x is greater than negative 3. I divide by a negative, so I get x is less than 1. That's because I divided by negative 3. Or negative 3x is less than negative 11. I divide by negative 3. I get x is greater than 11 thirds because, again, it was flipped because I divided by a negative. All right, so let's see what happens here. All right, x is less than 1 or greater than 11 thirds. So if I make my number line, I might do that first just so I can kind of see what's going on. 11 thirds is 3 2/3, so that would be up here somewhere. Greater than 1. So it said greater than 11 thirds or less than 1. All right, so that's what our graph would look like. It's an OR problem, so we knew it was probably going to be a union, especially for absolute values. And that's the end there. Negative infinity up to 1, parenthesis, union, 11 thirds to infinity. Okay, let's try number 2. 8 plus 2x is less than or equal to 2. Okay, so we're going to take a look now at a absolute value is less than 2. All right, less than or equal to 2. All right, and the equal to, by the way, and you'll notice here I did open circles. Here will be closed circles, so that equal sign still does the same task. All right, so let's try this out. 8 plus 2x is less than or equal to 2. So you write it exactly as it is with no absolute value. And because it was less than 8 plus 2x, guess what I'm going to do? Flip, flip. So again, flip inequality and flip the sign. Okay, so I had a negative and I flipped this to be greater. All right, and then we just solve both of these. We kind of see what comes out as our compound inequality and graph that answer. So I subtract 8, I get negative 6. Divide by positive 2, I get x is less than or equal to negative 3. And, let's see, subtract 8, I'd get negative 10. X is greater than or equal to negative 5. Okay, so x is less than or equal to negative 3 and greater than or equal to negative 5. And means both things have to happen at the same time. So if I try graphing this, negative 5, negative 3, I know I have closed circles because they were equal to. All right, and it has to be less than negative 3 and greater than negative 5. So again, when we see an and problem, we're looking at in between. Okay, that's pretty much what this always gives us. So final answer, negative 5 to negative 3. No unions. We're just talking about in between negative 5 and negative 3. All right, so that is the answer for that one. Let's look at the bottom two here, actually. So I'm going to hold on to 3 and 4, if you guys are okay with that. I'm going to actually look down here at number 5 and 6. Okay, so if I were to first, by the way, the very first thing you have to do is get the absolute value by itself. So 4x minus 3 is greater than, subtract 6, negative 3. So I want you guys to think, before you even start this, when is an absolute value greater than a negative? When is an absolute value greater than a negative? Always, right? So your final answer would be all real numbers, which is negative infinity to infinity. If you had to graph it, it would be this, that way, right? All the way from negative infinity, every real number up to infinity, all right? And that makes sense to us because what we just said, absolute values are always positive. So when is a positive greater than a negative? Always, all right, always. So look out for that. If you accidentally did the whole greater thing, it actually will work out. You'll end up doing something like this, where you have like greater than this number or less than this number, and you'll end up coloring the whole line anyways, and that will tell you, really it should have been all real numbers. Okay, and to finish up with number 6, another kind of tricky one here. It says 3x minus 1, first we subtract 5, so we get when is the absolute value less than negative 3? When is an absolute value less than a negative? When is a positive less than a negative? Never. Empty line, and literally we wouldn't write any type of interval. Sometimes you'll see it written like this, like the empty set, but we can just write no solution, and there are no real numbers that would satisfy this equation or this inequality. All right, so just wanted to show you those two special cases. In class, we'll try out one more less than and one more greater. All right, so get those ones down. Biggest thing you can take away here, make sure you're feeling comfortable with those two kind of goofy words, less than, greater, when we use them, and still make sure you're feeling good about interval notation and graphing inequalities. All right, so thank you so much for watching, and let me know if you have any questions.